Today we're doing 8.2, using random samples to describe populations. So we did talk about last week the difference between a sample and a population. Which one was the larger amount?
Population.
The population, okay? And then we learned that a sample was just a part of the population. Underneath that we learned two kinds of samples, unbiased and biased. Which one was good? Unbiased. There were two things that we wanted unbiased samples to be, large and random. Okay, so today we're going to be taking large and random samples that help us to discover some information. Before we get started, I want you to write down these things. Go ahead and pull out your red pen and write this down at the top section of your notes. How many of you would say that some of these words look familiar to you? You've seen them before. Okay, first up, a mean. What do we say a mean is? It's an average of the numbers in a data set. So let's just imagine that I've got the numbers 5, 6, 7, 9, and 13. How would I find the average or the mean of those? Does anyone remember from last year? What do I have to do, Einar? That is the first thing we want to do. You want to add all those numbers together. So somebody add those together for me, please. What do you get? Okay, very good. When we add them together, we get 40. Now, 40 is not the average. It's not the mean. I have to divide it by the number of numbers in my data set. How many numbers do you see here in the data set?
5.
There's 5 of them. So we're going to divide 40 divided by 5. What is 40 divided by 5? 8. Okay, so 40 divided by 5 is 8. The mean of that data set was 8. Okay, let's talk about the next one, the median. What is a median, class? The middle number. Looking at that data set, what would you say the middle number is? It's a 7. Okay, so 7 would be the median. However, in the parentheses, you can see it says if there's an even amount of numbers, then you find the mean of the middle two numbers. So let's just pretend that there was also a 21 there. What two numbers now are in the middle? 7 and 9. Okay, so if I was to take that right there, I would find the mean. 7 plus 9. What is 7 plus 9? 16. And divide it by those two numbers. What is 16 divided by 2? 8. Now, it also makes sense that if I was to stick a number in between the 7 and the 9, what number would it be?
8.
An 8. So that's how we came up with that. That would technically be the middle number if there was a middle number. Okay? The next one says the range. This is the difference between the highest and the lowest numbers. What's the highest number in that data set? 21. What's the lowest number? 5. What is 21 minus 5? 16. So then 16 would be my range of that data set. Now there's a formula here. If you would, draw a cloud around it because this is important. We talked about this last week and we're going to use this a lot throughout today's lesson. Favorable divided by the total surveyed equals n divided by the population. So we want to remember that formula. Finally, there's one last thing I want you to remember. Read me what it says down here. Always put estimates in order from least to greatest. Okay, so this information will be very helpful today during our lesson. For problem number 1, it says you and a group of friends want to know how many students in your school prefer pop music. There are 840 students in your school. Each person in the group randomly surveys 20 students. The table shows the results. So you can see it would be really difficult for me personally to go out and ask all 840 students. That's just a lot of students to ask. So I didn't do it by myself. How many friends did I get to do it with me?
4.
I got 4 other friends, okay, friend A, B, C, and D. So the 5 of us went out and each of us were assigned a certain number of people. How many did each of us ask? 20, okay, so it's kind of like spreading out the work, so it makes our job a little bit easier. The first thing we're going to do for this is the formula, and I want you to write this down. Well, first let's circle this. We're only focusing on the pop music, okay, so if you would circle that. We don't care right now who has country or who liked country, rock, or rap. We are focusing on who liked pop music. So now let's write this down. Favorable divided by the total equals n divided by the population. All right, the first person you'll see in the graph is you. You are the one who went out. So we're going to write you here. When you went out and asked people, how many people did you personally find liked pop music the best? 13. Out of how many people did you survey?
20.
You surveyed 20. So 13 out of 20, or divided by 20, equals n divided by, what was the population? 840, because there's 840 students in your school. Now for this, what I would like us to do, I know that we could do cross products, but for the sake of space and time, we're going to use mental math. So I'm trying to discover what n is. In order to do that, I have to figure out how to get from a 13 to an n, which means I have to figure out how to get from a 20 to 840. We are going to multiply, very good. And what would the missing link be? 42. Okay, so I'm going to multiply by 42 on the bottom, which means I'm also going to multiply by 42 on the top. Isaac, we know that 20 times 42 is 840. What is 13 times 42?
546.
Okay, 546. Now you can see they've already put that down here. See at the graph on A, 546 is how much that you estimated would probably like pop music. Now let's go on to friend A. So to the right over here, just write in friend A. Amira, how many people did friend A figure out liked pop music? 8 out of how many?
20.
Out of 20 equals n over the population. Remind me again, what's our population? 840. Now here's what's cool. The missing link is going to be the same, okay? To get from 20 to 840, what do we multiply by?
42.
Multiply by 42 on both the top and the bottom. So 20 times 42 is 840. Amira, what is 8 times 42?
336.
Okay, 336. Guess where I'm going to put that number? Under friend A in our box. Let's go on to friend B. Reese, how many people did friend B discover liked pop music? 10 out of 20 equals n over, what was the population? Very good. Once again, same missing link. We're multiplying by 42 on top and on bottom. Reese, how many people do you estimate for friend B like pop music the best? 420. Okay, and then I'm going to put that down in the box. Who notices something interesting about friend C?
He has a bunch.
The same thing as who? Notice friend B found out that 10 people liked pop music. Friend C found the same thing. So instead of redoing all the work that we just did, I'm going to write here friend C is the same as friend B. And how much was that? 420. So I'm going to put 420 underneath friend C. I want you guys to try to do friend D on your own. All right, so I saw a lot of you got this answer. 9 out of 20 divided by, or equals n times 840. We are multiplying by 42. What do you get when you guys do that? 378. Okay, so we just got a lot of information about the different friends and things that you guys came up with. Now looking at problem A, it says, use each of those samples that we just came up with to make an estimate for the mean number of students in your school who prefer pop music. So before we do anything else, what was the last thing we wrote in red at our notes at the top? Always put estimates in order from least to greatest. Guys, which one was the smallest one there? 336. I want you guys to write that directly underneath where it says you on your notes. What was the next one?
378.
378. Next?
420.
420, and then we have 420 again. And finally, 546. Now, I want to know one mean estimate for all of those numbers. How do I find the mean of those 5 numbers in the data set? Find the average. Okay, so we're going to add them all up together. When you add those together, what does it come out to? What'd you get, Noah?
2094.
No?
2002.
No?
2010.
2,100. It sounds like we're having some struggles adding, okay? Make sure you're putting the right numbers in there. 2,100. I have to divide it by the number of numbers in my data set. How many numbers were there? 5 divided by 5. And this number is going to give us the mean number of students in your school who prefer pop music. What's the answer?
424.
420, and then we're going to put units attached, students. There's a decent amount of work that we're going to be showing for problems like this. Tonight on your homework, problems number 7, 8, and 9 are going to be similar to this. So you're going to need to write out a lot of this kind of work right here to show me the steps, okay? So you're going to be using this kind of problem for 7, 8, and 9 on tonight's homework. Let's take this on to problem B. Okay, so I know on our last one, we had put them in order from least to greatest, which will have 336, 378, 420, 420, and 546. You guys don't need to rewrite that because you already had it on your paper. I'm just rewriting it because it's a new screen for me. Let's look at problem B. It says to describe the variation. When looking for variation, it's typically talking about the median and the range. So let's write the word median here. That's what we're going to find first. What does median mean? The middle number. Guys, what's the middle number in that data set? 420. I want you to circle the 420 with your red pen, just to kind of help you identify that is the middle number. And that would be 420 students. Now there's another word that you might see when doing your homework tonight or on a quiz or a test. Another word for median is center. So if you would, use your red pen and I want you to write the word center. Does it make sense for another name for median to be center? Yes, why does that make sense? Because it's the middle number. It is the center number of your data set. All right, there's another thing we want to find, not just the median, but the range. Let's go back to our notes on the front page that we took. Guys, what does the range mean? The difference between the highest and the lowest numbers. What was the highest number in our data set? 546 minus, what was the smallest number? 336. Trenton, what is the range? Very good. 210 students is our range. All right, for problem number 2, you want to know the mean number of hours students with part-time jobs work each week. 10 students were asked at each school, and 6 different schools are represented. So you can see here we have school A, school B, school C, D, E, and F. So they have asked 6 different schools this survey. We're going to kind of divide up our information. So if you would, write an A, B, C, D, E, and F. Let's focus on the first school that they went to and asked. Let's pretend this is Trinity, okay? Trinity is school A. So we are going to focus only on the information right here in A. I want you to find the mean of those numbers. Okay, in order to find the mean, we're just going to be adding up the number of hours that those 10 students at Trinity worked. What'd you find? 70 divided by, how many students did they ask at Trinity? 10. 70 divided by 10 equals? 7. I'm going to put that information down here in the box. School A had 7. Let's go on to school B. What's a school that could be school B? Bulls, okay, B for Bulls, I like it. Let's add up just school B now to see how many hours they worked. Okay, so we're just focusing on this next section right there. All right, 73 is the total number of hours for the school at Bulls, divided by how many students did they ask? 10. What is 73 divided by 10? 7.3. All right, let's put that down at school B. Now we're going to move on to school C. What could be another school? Anyone?
Lake Asbury Junior High.
All right, Lake Asbury Junior High. So we're focusing here only on Lake Asbury Junior High. Let's add those up and see how many total hours they worked. Matthew, what was the total number of hours you got from school C? 77 is correct. Divided by, they asked 10 students. So class, what's 77 divided by 10? 7.7. I'm going to put that down here in the box. Now I want you guys to focus on schools D, E, and F. It's going to be done exactly like we did A, B, and C. Okay, so take a couple minutes and do that part on your own. All right, let's see what we got. On problem D, when you added them together, what'd they get? 50 divided by 10, which equals? 5, very good. E, 80 divided by equals 8. And finally, F was divided by equals. All right, very good. Okay, so we have figured out the mean number of hours per school. Problem A asks us to use the information to make one estimate. So I don't want the mean for 6 different schools. I want one mean for all of those put together. So the first thing I have to do is put them in order from least to greatest. Okay, what's the smallest one? 5. Then 7.3. No, 7 would come before that. Then we've got 7.3. Then we have? And then? And finally? Okay, so if you add all of those up together, what do you get for the total number of hours for that? What is it? 44 is correct. Now we've got 44 divided by, how many schools did they ask? Divided by 6. What is 44 divided by 6? 7.3 repeating. So this tells us that 7.3 hours would be the mean number of hours that the students worked. Now we've got problem B. It asks us to describe the variation, which means the median and the range of the estimates. So let's write median down, and then let's write range. Remind me again, class, what does median mean? The center or the middle number. What's the center number here? There's 2 middle numbers. I want you to take your red pen and circle both of those numbers. Remember what our instructions said. If there's 2 numbers that are in the center, I have to figure out what number would technically land right here in the middle of those 2 numbers. So remember, I can do that by finding the mean of those 2 numbers. So let's add them together. 7.3 plus 7.5, or 7.7, sorry, divided by 2. When I add those 2 together, what do I get? 15 divided by 2 equals 7.5. Now, doesn't that make sense that 7.5 would be stuck right there in the middle of 7.3 and 7.7? Because it comes directly in the middle. All right? So when finding the median, you want to find out what would have been the middle number if there's 2 numbers there. Finally, let's talk about the range. Matthew, how do I find the range? You are correct. So what's the biggest number in our data set? 9. Subtract the smallest number, which was 5. What's the answer? 4. Okay, so the range is 4 hours. So for this one, I've got a review problem. You go out and you ask 100 7th graders if they want to get rid of the rule that students must wear a uniform to school. How many of you guys would want to get rid of that rule? Okay, it looks like quite a few people in here. Is there anyone who likes wearing a uniform to school? All right, nobody in this class. So we are going to try to figure out from this data right here whether or not our conclusion is valid. So looking at problem A, you conclude that 88% of the 7th graders do support this new rule of getting rid of the uniforms. Do you think that's a valid statement or an invalid statement?
Valid.
It is valid, okay? So remember, there's 2 things that we want to make sure we do whenever we have a valid statement. We want to make sure that it is large and random, okay? They asked 100 people here. That's a large sample, all right? And they did it randomly, so the sample was large and random, which means that this is a valid and good conclusion. All right, let's look at problem B. You conclude from this data that 12% of the 12th graders do not support the new rule. Valid or invalid? I'm hearing a lot of invalids. Invalid is correct, but why is this an invalid statement? No? They still got their information from up here. They asked 100 7th graders. So it was large. It's just their conclusion figured out that 12th graders, 12% of them don't support the rule. That's exactly what it is. Look what it's concluded, that the 12th graders don't support the rule. Did I go to the 12th graders to try to get information from them? No, okay. Who did this thing survey? Okay, so instead we need to write out, it surveyed the 7th graders, not the 12th graders. So their conclusion was not valid because they were talking about conclusions that could have come from asking 12th graders. So for this, it surveyed the 7th graders, not the 12th graders. Okay, so remember, anything that's on my slide you need to also write down in your notes. Okay, for our last problem today, it says to write and solve a proportion to answer the question. Remind me again, guys, what is a proportion? It's two fractions that equal each other. Everyone say two fractions that equal each other. Okay, so what is the formula of two fractions that equal each other? Is over of equals, very good, is over of equals p over 100. So we're going to start with that formula. And now we always talk about underlining and circling certain things. Angeline, what should I underline? Okay, underline 15 is? Very good. Okay, so we're just separating it into our is, our of, and our p. Reese, what is the is?
15.
Gavin, what's my of? 60. And then equals p over 100. We're going to do some cross products here. On the left side, remember we always want to have our variable, so we're going to do 60 times equals 15 times 100. Huang, what is 15 times 100? What is it?
1,500.
Okay, 1,500. Hope, how do I get p by itself?
By 60 on both sides.
Divide by 60 on both sides. And when I do that, Hayden, what do I get? 25, very good. Now my answer is not 25, just plain, because if I go back it says 15 is what? Percent of 60. So I'm going to go ahead and stick 25% would be the correct answer. All right, tonight's homework, there's going to be two problems that look just like that on your assignment. So for tonight's homework, we are working on 8.2, and there are 7 problems for this assignment.